So in this video, I'd like to talk about factoring. So factoring, the root of it is the word factor. So what is a factor? A factor is a number that times another factor, another number, creates a product, okay? So a product can be broken down into factors, okay? So 6 could be broken down into times 3. 8 could be broken down into 2 times 4, and so on. 16 could be broken down into 4 times 4, okay? Now 16 has other factors as well. 16 could be broken down also into 2 times 8, or even 16 times 1. All of these are factors of 16. So it's like all of these are examples of factoring 16. Okay. Since we're doing algebra where we're working with variables, let's try to do it with variables as well. Okay, if we have 3x, what does that mean? That means we're multiplying 3, the coefficient, times x, the variable, okay? There's no multiplication symbol in there because they're touching, and that means that it is implied that they're being multiplied. But if you want, at any time, you can always feel free to put in the little multiplication dot if you feel more comfortable doing that. That's totally fine. So the term 3x can be broken down into its factors. So its factors are 3 and x, okay? Just like 6 could be broken down into its factors of 3 times 2, 3x can be broken down into its factors of 3 times x. So we've just done some factoring of 3x, okay? So factoring, if you want to think about it, is kind of like, it's like working backwards. You start with a product and then you break it down into its original parts that were multiplied together to get this larger number in the first place. Okay, so let's say that we have something like, I don't know, maybe 6x plus, how about 12? Okay, this is an expression, all right? It's 6 times x, and this product, 6x, is going to be added to 12. Let's see if there are some common factors between 6 and 12, or 6x and 12. Well, there is a common factor of 6. So 6 is in here because it's 6 times x. I'll just underline that to underscore that 6 is a factor of 6x. And 12 could be broken down into lots of things like 3 and 4 or 12 and 1, but it could also be broken down into 3 times 4. And I'm going to underline, oh, I'm sorry. I'm sorry. Yes, it could be broken down into 3 times 4, but that won't help us here. What I want to use is 6 times 2. 6 times 2. Now do you see that there's a common factor between both 12 and 6x? What is that common factor? That common factor is 6. Okay? So that's how we start to factor these expressions. We try to find a common factor, and maybe the largest common factor between these two numbers that are being added, or sometimes they're being subtracted, okay? Okay, so keeping that in mind, I want to go back to the idea of distribution, okay? So the idea of distribution is we have a number that's on the outside of the parentheses, okay? And then we have variables and numbers on the inside of the parentheses. And what's the first thing that we do? If there are any subtraction symbols, we turn them into plus negatives, okay? And then the second thing is we put a little dot here to remind ourselves that 6 needs to be multiplied against everything in the parentheses. So here 6 needs to be multiplied by x, and then 6 needs to be multiplied against 2. So let's do the distributive property here. So we get 6x plus 6 times 2 is 12. Okay, so we have 6x plus 12. We multiplied 6 times this package x plus 2. okay? And we got the product, this is the product. We got the product of 6x plus 12 by multiplying this times this. What are things called when you multiply this times this? We call them factors, okay? Just like the factors of 6 are 2 times 3. Well, here, the factors of 6x plus 12, the factors are 6 and x plus 2. So this whole thing, it seems a little strange, but this entire package in the parentheses is considered a factor. X plus 2 is considered a factor. And 6 is considered a factor. So that when you multiply them together, you get back to a product. So we're working backwards. When we want to factor 6x plus 12, we break it down into its component parts. Okay? So, how do we break it down into its component parts? We try to extract the greatest common factor from both of these terms. And the greatest common factor from both of these terms is 6. Now, you could think of other factors that you could pull out from both of these. 2 is a factor of 6, as well as 6x, as well as a factor of 12. Okay, so we could do it. Let's say we pulled out 2. If we pull out a 2, what do we need to multiply 2 by to get back to 6x? How about 3x? Okay, and then we bring down the addition sign, and then if we're pulling a factor of 2 out of 12, 2 times what gets us back to 12? 2 times 6, okay? So you could say that this is also a version of factoring this original expression, but we don't want to do this as our final answer because this is not fully factored, because there's even more that we can extract from 3x and 6. 3x and 6 also share a common factor, that factor being 3. See, 3 goes into 3 once and 3 goes into 6 twice. So 3 is another factor that could get pulled out. So this is incomplete. It's not complete. If we want to pull out the 3 from here and the 3 from here, then we would be pulling a 3 onto the outside here. 3 times 2 is 6. And then we would just be left with x plus 2 in here. So 6 is the greatest common factor that you can pull out from each of these. And that's why 6 is going to be on the outside to fully factor this expression. Let's do another one. Let's say that we have 12, well, let's pick another number. How about 24y minus 4? So this is our expression, and we want to factor it, okay? Which means we want to pull out the greatest common factors that both of these share, okay? So what does 24 and 4 share as a greatest common factor? 4. 4 is the greatest common factor. So we could extract a 4 out. We put it on the outside. We bring down our subtraction sign. Okay, so 4 times what will give us 24y? 4 times 6y. 4 times 6y, if we distribute that, we get back to here. Okay, here, what do we need to multiply here to get back to this number? 4 times what equals that? 4 times 1, okay? So this is the fully factored form. There are no common factors between 6y and 1, so we fully factored as far as we can go. Okay, so this is the answer. This is what the answer looks like. 4 times 6x minus 1 gives us the product right here. Okay, so this is a factor, this is a factor, this is fully factored. Okay, how about 9 minus, say, how about 36y? So this is our, and we're trying to think of something that we can pull out of both. Well, we can pull 9 out of both because 9 is within here and 9 is within here. So we'll pull out the 9 Bring this down. What do we need to put here to get back to 9? A 1. 9 times 1 is 9. What do we need to pull out of here? A 4. Or we pull out the 9 and we're left with a 4y, because 9 times 4y gets us back to 36y. If we distributed this, we'd get back to that. Okay, one more, and I'll let you do a couple of these yourself. How about 26 r minus, say, 50. Okay, so what does 26r and 50, what are their greatest common factors? I think the greatest common factor is not very high. I can only think of a 2 as being going into both of these an even number of times. So the most we can extract is a 2. That's okay. So we'll bring 2 on the outside times, and we'll put this subtraction sign here. By the way, if this was a plus sign, we would bring the plus sign down. It's okay. Okay, so 2 times what gives us back to 26r? 2 times something r, how about 13? And 2 times what is 50? 25. And there's no common factors between these two terms, so that's as much as we can go. This is our fully factored form, okay? So this is our answer. This is what our answer looks like. This is a factor, this whole thing's a factor, you multiply them together, you get back to our product. I'll let you do a couple where you're gonna practice factoring.